In this second tutorial, we will solve a quadratic equation over the set of complex numbers using the quadratic formula method. So let's flip to example 1. We're going to solve for x. Here's our equation. X squared plus 6x plus 14 is equal to 0. The first thing we need to make sure is that we have our quadratic equal to 0 and that it is in standard form. So we can find the values of a, b, and c. That should always be the first thing that you're finding, your coefficients. Well, the value of a is 1, the value of b is 6, and the value of c is 14. Great, so we have a, b, and c. Where I like to begin is the discriminant, the b squared minus 4ac part of our quadratic formula. So let's find that. I'm going to square b, so I take my 6 and I'm going to square that, so 6 squared. Minus 4 times I'm going to plug the 1 in for a, and I'm going to plug the 14 in for c. 6 squared is 36. This is negative 4 times 1 times 14. So that is negative 56. 36 take away 56 is negative 20. I have found the discriminant, and since the discriminant is a negative value, I know that I have two complex roots. Two complex roots. Now that I know that the discriminant is negative 20 and that I'm going to have imaginary answers ultimately, now I can go and plug into my quadratic formula. So I'm going to come over here. I'm going to write the quadratic formula down every single time, and I encourage you to do that as well. It helps to get it into your brain faster. It's the opposite of b plus or minus the square root of b squared minus 4 times a times c all divided by 2a. There's our quadratic formula. There are three parts to the quadratic formula that I'm going to plug in. The opposite of b, the 2a, and then this b squared minus 4ac. This is really where the majority of the work is. That's why I like to start it first and get that number. So now I can just plug right into our equation, into our formula. The opposite of a number is pretty easy to do in your head. The opposite of 6, of course, is negative 6. Plus or minus the square root of b squared minus 4ac. I already found it. It's negative 20. So here it goes, negative 20. 2 times a number is pretty easy to do in your head as well. 2 times a would be 2 times 1, which is 2. So now we've plugged into our quadratic formula. Next, we typically simplify our radical, the square root of negative 20. I'm actually going to come off to the side and deal with that as sort of like a separate problem. The square root of negative 20, we know that the negative sign cannot be underneath the square root, so it's going to come out as an I. So I times the square root of positive 20. And then I can break apart my square root of 20. And square root of 20 has many numbers that go into it, but the most interesting is the perfect square 4. 4 times 5. So this is I times 2 times the square root of 5. Most people change this to write it as 2i square root of 5. Now that I have that, I can bring it on back into my formula, and I have x equals negative 6 plus or minus 2i square root of 5 divided by 2. Usually I'm finished by now, but in this case I can see that I have even numbers here, here, and here. That means that all three of them can reduce. You have to be able to reduce in all three spots, or you cannot reduce at all. So I know that negative 6 will become negative 3, plus or minus 2i square root of 5 turns into 1i square root of 5. And then 2 turns into a 1. I don't really need that, so I'll just use that for my box. And those are my two answers. Complex, negative 3 plus or minus I square root of 5. And there's our first one. It's just plugging into a formula. The numbers will change, but the formula will stay the same. So there's a problem right here in example 2. It's not equal to 0 yet. That must be your first step. In fact, almost every quadratic equation that you're going to solve, you should set it equal to 0 before you begin. It needs to be in standard form. Now that it's in standard form, I can pick off my A, my B, and my C. A is the value of 3, B is the value of 1, and C is the value of negative 2. Watch out for your signs. They go with your coefficients. I like to do my b squared minus 4ac. This is our discriminant. So b squared becomes 1 squared minus 4 times the value of a is 3. The value of c is negative 2. 1 squared is 1. This is negative 4 times positive 3 times negative 2. I know that two negatives multiplied together is going to make a plus. 4 times 3 times 2 is 24. 1 plus 24, of course, is 25. This time our discriminant is positive. That means that I have two real roots. But since it's also a perfect square, because 25 is 5 squared, these are going to be rational. Nice numbers. The radical will ultimately go away. Two real rational roots. And now that I have that, I can plug it right into my quadratic formula. Let's write it again. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And now let's plug in. The opposite of b is pretty easy to do. It's the opposite of 1, which is negative 1, plus or minus the square root of, I already found it, it's right here, 25, divided by 2 times a is 2 times 3, which is 6. Great. The next thing I'm looking at is my square root. Actually, the square root of 25, because this is a perfect square, I could just go straight into what it's going to be. This is negative 1 plus or minus. The square root of 25 is just 5. Awesome. There's no work off to the side necessarily because it's just a perfect square. And now, since these are like terms, I can combine them together. In fact, I'm just going to split them up into the two things. I'm going to write negative 1 plus 5 divided by 6, and I'm going to write negative 1 minus 5 divided by 6. I'm going to split up this plus or minus symbol to find my answers. So what do we have here? Negative 1 plus 5 is 4 divided by 6. Negative 1 minus 5 is negative 6 divided by 6. These can now, of course, reduce. 4/6 becomes 2/3, and negative 6 over 6 becomes negative 1. Just like I said over here, two real rational roots. Rational numbers are numbers that can be written as fractions. All right, moving on to example 3. Got to practice our quadratic formula. Again, we do not have it equal to 0. So I am going to subtract our 4x. It is important to understand that it's going to go right here in the middle because it needs to be in our standard form. X squared minus 4x plus 13 equal to 0. We want to get our 0 so that we have our standard form. A, B, and C should be what you're finding first. The value of A is a 1. The value of B is negative 4. The value of C is 13. Great. I like to do my b squared minus 4ac, so let's do that first. Majority of the work is really right here. B squared, this is negative 4 squared. Look at me, I'm so smart. I put it in parentheses so that I do not mess that up. The number negative 4 squared will be a positive. If you're using your calculator to plug this in, you need your parentheses. A is a 1 and C is a 13. Negative 4 squared, of course, is positive 16. This is negative 4 times positive 1 times positive 13, and that is negative 52. 16 take away 52 is negative 36. Again, we have a negative discriminant. That means that we have two complex roots. We will have imaginary answers again. Complex roots. Now let's go see if we can find them. Come on over here. X is equal to the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. The more times you write it down, the easier it is for you to memorize it. So let's see what we have. The opposite of b becomes positive 4 plus or minus the discriminant, which is the square root of the discriminant, negative 36, divided by 2 times a, and 2 times a is 2 times 1, which is 2. Some people might want to come off to the side. Since this is relatively a new topic, the square root of negative 36, the first thing you need to do is take out the I, and then you have the square root of positive 36. But this is a perfect square, and this ultimately becomes 6I. Some people will just go right into that from the square root of negative 36, right into 6I. That's fine. If you want to show some work off on the side, that's cool as well. So this becomes 6I. 4 plus or minus 6I divided by 2. And then we have a similar thing as before. We have even numbers in all three spots. Again, as long as it's all three spots, we can reduce in all three spots. 4 cut in half becomes 2 plus or minus. 6I cut in half becomes 3I. And 2 cut in half becomes 1, which I don't really need anything divided by 1. So I'll use that division bar as part of my box to box in my answers. 2 plus or minus 3I are our two answers. Complex, we knew that from the discriminant. Let's keep going. There's one other type I'd like to show you. Example 4. This is nice. It's already in standard form. It's already set equal to 0, so I can find my A, I could find my B, I can find my C. I like to pick them off over here so I don't mess anything else up. A is a 2, B is a negative 6, and C is a negative 1. B squared minus 4AC is where I'm starting, so this is negative 6 squared minus 4 times A, which is 2, times C, which is negative 1. Negative 36 squared, of course, is positive 36. I see a negative times a negative. That makes a positive. 4 times 2 times 1 is 8. 36 plus 8 is 44. Positive again, which means we're going to have two real roots. But because 44 is not a perfect square, these are going to be irrational, meaning ultimately that the radical sign is going to stay in our answer. Two real irrational roots. Let's go find them. Quadratic formula says x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2 times a. So let's simplify, or let's plug in. The opposite of b, negative 6 is what b is, so the opposite of that would be positive 6. Plus or minus the square root of the 44 that we already found. 2 times a is 2 times 2, which is 4. I want to point out that we cannot reduce right now. There are 3 locations in this fraction, and only 2 locations have an even number. This location has a 1 outside of it, so it is not ready to reduce. But square root of 44, I can do something with that. What goes into 44? Hopefully you're seeing 4 times 11. So the square root of 4 times the square root of 11, that sounds good, because the square root of 4 turns into a 2. Square root of 11, of course, is going to remain, which is why we have irrational roots. I'm going to bring that on back in, and let's see what we have here. We have 6 plus or minus, I'll put my 2 square root of 11 divided by 4. Now, hopefully, you can see that we can reduce in all 3 spots. 6, 2, and 4 are all even, so I can cut everything in half. 6 cut in half is 3. 2 cut in half is a 1, but I don't really need it since I have the square root of 11 there. 1 square root of 11. 4 cut in half is 2. So I have nice fraction answers this time. So we've just done 4 examples using our quadratic formula. You can see that all 4 of them are very similar in terms of the process. It's just some math that will change from time to time with different numbers, but that is our quadratic formula. It's kind of fun once you learn that process. I do have one last example, and it is our word problem. It says the equation for an object's height, which they said is s, at time t seconds after launch is given as, well, I like when we get the equation. Whenever they give you the equation, it's going to be kind of pretty simple to do because they've given you all of those numbers and variables. It says, when does the object strike the ground? So here is our quadratic equation, and it is in standard form. We've got our quadratic term and then our linear term and then our constant. Don't get afraid that these numbers are huge. We've got our calculators to be able to deal with that. And hopefully we can understand kind of what this picture looks like. Let me draw it. We've got this this thing, that's this object that's being launched into the air, and it's being launched into the air, and of course gravity is going to take hold of it and it's going to come back down. And that's ultimately what we want to find out. When is it going to come back down to the ground? Here's my ground. So ultimately, if we think of the ground as the x-axis, then we're looking for an x-intercept. And if we're looking for an x-intercept, then we're looking for a root or a solution or a zero. So that means we could use the quadratic formula. There are other methods that we could use to solve, but I'd like to do quadratic formula. Ultimately, we want to know when s of t is equal to 0. When this equation is equal to 0. So it is in standard form, and once we set it equal to 0, we'll be able to find our zeros. So let's find A, B, and C. I know that these numbers are going to be relatively large here. B is 97, my goodness. 75 for C. Let's find our discriminant first, b squared minus 4ac. So b squared is going to be 97 squared. No idea what that is. I'm going to have to use a calculator. A is negative 4, and C is 75. All right. So let's pull up our handy-dandy calculator, and let's do 97 squared. So 97 squared. We've got 9409. 9409. This is a negative times a negative times a positive, so I know that it's going to be a positive. And let's see what we have. We have negative 4 times negative 4 times 75. Positive 1200. All right. And we're adding these two things together. So 1200 plus our 9409 gives us our ultimate discriminant of 10,609. 10,609. Now I know that this is positive, which is good because we're going to have real answers. But I have no idea if this is a perfect square or not. So perhaps I just check real fast on the calculator. Let's do the square root of that answer. So I pushed second and then the squared button to get the little blue square root. I don't want to have to type this in if I don't have to. Since this is the previous answer, I could type or push the second button, and then you see the little ants above the little negative button, second answer. This will tell me the square root of the previous answer if I press enter, and that's kind of helpful to save some time. Oh, yay, it is a perfect square because I don't see any decimals after that. So 103. So that'll come in handy in a little bit, I guess. So now that we know that that is a perfect square, I know that not only are they real, but they will be rational roots. Two real rational roots. The discriminant told me that. Now let's go plug into our quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. Opposite of b becomes negative 97 plus or minus the square root of my 10,609 all divided by 2 times a. 2 times a would be 2 times negative 4, which would be negative 8. Now, because I've already used the calculator, I know that the square root of 10,609 is a perfect square, and it was 103. And now I can see that I can split up. I don't really need the plus or minus. In fact, it's probably more confusing with it there. So I'm going to write this as two separate numbers. Negative 97 plus 103 divided by negative 8, and negative 97 minus 103 divided by negative 8. So let's see what we have here. I'll probably use my calculator again. I covered up my work. So I've got negative 97 plus 103. So negative 97 plus 103. Enter. Let's see what that numerator is. It's 6. So that's 6 divided by negative 8. Well, that doesn't really make much sense. Because if we're talking about a time, it says when, we're not really talking about a negative. So it must be that our y-axis is right here, and we must have been launching this thing not from the origin, but something above the origin. So we're not really interested in this x-intercept. So I'm not interested in this number right now. I'm interested in the other number probably, though. That's going to be negative 97 minus 103. Let's press enter to get that numerator. That's negative 200. And it's divided by negative 8. Negative divided by negative, that's going to sound a little bit better. Let's divide it by negative 8, and we'll have our answer of 25. Word problems should always end in words. It says, when does the object strike the ground? So we're going to say 25 seconds. It says that our time is measured in seconds. So we can use our quadratic formula to solve a word problem like this. Fantastic. Thanks for watching this tutorial. We showed you 5 examples for solving a quadratic with the quadratic formula. Please memorize the quadratic formula, perhaps write it down another few times from memory, and we'll see you in class to practice this material. Thanks for watching. Bye-bye.